Okay. And yeah, other than keeping an eye on our YouTube channel, we've been pretty active in our LinkedIn profile these days. So if you want to connect or see the latest updates about what's going on, uh, would be great to follow us there. And so now I'll officially welcome you to the October 2023 Virtual Quality Talk. It's always so nice to come back to these after the summer break and after the conference. So excited to see everybody here today. So as always, I'd just like to send out a big thank you and recognize and acknowledge the amazing KWSQA board members who work hard to keep the organization running throughout the year and bring you these events, and really appreciate everybody's help with all of that. And D2L is on our thank you list as well because they continue to allow us to use their Zoom account for these events. Similarly, on the note of being thankful for things, we want to acknowledge our thankfulness for the ability to live and work and build our software quality community in such a great region. And the land where the KWSQA office is located is on the Haldeman Tract. This is land that was promised to the Haudenosaunee people of the Six Nations of the Grand River. It's also within the traditional territory of the Neutral, Anishinaabe, and Haudenosaunee peoples. So again, very thankful to be able to build our community in this region. As for code of conduct, our code of conduct for the KWSQA always applies to all of our events, either virtual or in person. So please do reach out if you ever have any questions about the code of conduct, or if you need to report an incident in any way. Connect directly with one of our board members, or you can reach all of us at info@kwsqa.org. So other than coming to these quality talk events, there's some more ways you can get involved in the organization. One of which is you could be a presenter at one of these events. We're always looking for great talks to share with our group. And so you can submit a proposal through our form that you can find from our website there, the top left. If you're a local company and interested in getting some feedback on the software that you're building, we can work with you to host a testing games event. And so again, there's a form to submit a proposal for that. If you are interested in our mentorship program, you can find more information on the website too. Either if you're interested in being a mentor or a mentee, we're always looking for both. So it would be great to hear from you on that. You can buy a membership to the KWSQA on our website. Even though these quality talk events are free and don't require a membership in order to join, it's still a good way to support our organization. And it also allows you to vote in our annual election and run for a position on the board. And more on that in a couple of slides, but you'll see the Buy Now button on the website there. And finally, you can also sign up for our mailing list. And again, this is another good way to keep informed about all the things going on in our organization. Just a quick thank you. We had such a good time at Targeting Quality, just over a month ago now, and it was so great to see so many people come out, and it's always nice to get together in person and share food and all that good stuff. So thanks for helping us to make it another successful Targeting Quality conference. We've got our next couple of quality talks planned out. So there's one at the end of November, and then we take a break in December as usual, and we'll resume at the end of January with another one. So we hope to see you out at those upcoming events. So getting back to the AGM, annual general meeting for the KWSQA, and our upcoming election, here's just an overview of some key dates. We're taking nominations for people who would like to run for an open board position that we have this year. We're taking those up until November 2nd. So just over a week, I guess, to get any nominations in. You can nominate yourself or somebody else. In order to run, though, you'll need to be a member of the KWSQA. You can purchase a membership up until November 24th if you want to be eligible to vote in the election. So keep that date in mind. We'll run the election between November 27th and December 1st, and we'll announce the results at the AGM, which is on December 6th in the evening. It'll be a virtual meeting, and if you're a member, stay tuned for an invitation to that. Finally, if you complete the survey that you receive after this meeting about what you liked or didn't like about this meeting, you'll be entered in our annual draw where you could potentially win a $50 gift card, so keep that in mind. And okay, we're getting to the good stuff now. I would like to introduce today's presentation. Thank you, Rashmi, for joining late in the evening, your time zone, to tell us some of what you've learned and what you know about building fair, accountable, and trustworthy ML systems. We're excited to hear this talk. We had originally kind of hoped that it could be in person at Targeting Quality, but maybe we'll get you out at Targeting Quality in a future year. But for today, still really happy that we get to hear this talk. And at this point, I will turn things over to you.
Thank you so much, Rina. It's lovely to be presenting in here. Now I'll be sharing my screen, and I really hope someone can just let me know if my screen is visible.
I can see it.
Still loading. Okay, awesome. Hi, everyone. I'm Rashmi Nagpal. I'm a software engineer by profession and a researcher by passion. And I'm super excited to be presenting on the topic, which is building fair, accountable, and trustworthy machine learning systems. So without any further ado, let's begin. So first of all, the agenda of this talk is I'll explain what is machine learning and systems to bring all of us on the same page. And then we'll understand what's a black box model. Then we'll understand what is a machine learning test pyramid. And further on, just building on those pre-existing concepts, we'll understand how we can build the test-driven developments for the FATE. FATE implies that fairness, accountability, trustworthy, and explainability in ML systems. And what are some technical debts? And further on, we'll just conclude with certain resources for the future reference. So let's begin on this ride together. It's just, okay. So, what's the machine learning? So, like AI, it's kind of a very broad term, which implies that, you are creating kind of a program or just kind of a technique, which is kind of mimicking the human behavior. While machine learning, it's a subset of AI, in which you are not just developing some algorithms, but you're training those algorithms from some pre-existing data set. For example, a spam email detection, it's an example of machine learning. While the deep learning, it's built upon machine learning concepts, but going a further step beyond it, that you are extracting the patterns from the data set using some neural networks, and then it gives you some data-driven decisions, right? Or you can say that a handwriting recognition or Google Assistant, these kind of all these models, conversational styles, recommendation systems, these are all the applications of deep learning. Okay, so now I can explain you the basics. Let me test the waters. I just want, I think Tina will pose this question on the chat in itself, but I just want you all to take a minute and think which of these faces are real, or which of these humans exist on the planet Earth, to say the least. And I would love to hear the answers. Maybe like, I don't know, I can see the stats of the folks. Those will be answering this question, but that's a very lovely question. I would love to hear what's the audience poll in this.
I've created the poll. Let me see if, okay, do people see it now? I'm not very experienced with creating polls in Zoom. Are you guys able to answer the question? Okay, answers are coming in. We're good.
But what is the question?
Okay, I can repeat the question. So the question is, which of these faces are real? Is that the face A is the real one, face B is the real one, or face C is the real one?
What does it mean, real?
Okay, what does that imply? Real in a sense that whether these people exist on the planet Earth. I mean, you can easily detect between the real and a fake human, right? Some of the applications of the deep generative modeling does imply that whether that person actually exists versus not. So in that way, I'm just saying, I'm asking, like whether that person is real or not.
Where are options D and E, all of the above and none of the above?
I didn't quite understand this one.
Two options are missing, all of the above or none of the above.
Just play along with the poll as it is. Well, we don't need to
But it's a
take it
biased poll.
too seriously.
I cannot answer it.
Okay, you can skip the poll if you don't want to. That's okay.
Thank you.
Okay, so
It's
I
not
see
mandatory.
Right. Sure, but that's a fun question I just wanted to ask. Okay, so 50% of the audience have answered that the face B is a real one. And approximately, I see that a 7 on 16, like 44% of the folks have answered that the face A is a real one. And 1% has said face C is a real one. Well, the answer is none of these faces are real. None of these planet or people exist on this planet Earth, to say the least. I'm not sure about the extraterrestrial planets or the Andromeda galaxy for that matter. But yes, so these people, they do not exist on the planet Earth, and these are the application of the deep generative modeling. So what happens in the deep generative modeling is, you are not just training models on the existing data set, which is a human faces publicly available data set, but you are also creating brand new data instances, which is going a step beyond an existing data set. So it becomes like quite hard in order to distinguish, whether that's a face is a real or whether that the new data which is generated is a real one or not. And you must be aware about the Chat GPT or DALL-E. These are some of the applications of deep generative modeling, which has been released by the OpenAI company. Okay. But what's the building block behind all these models? Machine learning, it could be, or either it could be any deep generative or deep learning model. So let's see that. So you can see the basic neural network structure. You have given a data set as an input, the input which is being fed in the model. And consider right now the machine learning just as a black box, which comprises of weights, sum and bias, and activation function. And then it gives you some output. And output could be, whichever the use case that you're trying to cater to. For example, if you're building an image recognition or maybe a recommendation system or maybe a sentiment analysis kind of a system. So that's what the output you will get on basis upon the use case that you are trying to cater to, right? So that's how the neural networks, which are working in the mathematical concepts behind the scenes and gives you the very decent output. Now let's understand this basic neural network structure through an example. So this is an image recognition example, and that's my Fluffy, my pet dog. So given an image of any animal, you need to recognize to which animal category that image belongs to, right? So here you can see the image data set being an input. Now you use some machine learning algorithms on top of it, and it gives you an output with certain accuracy or certain confidence. It states, okay, now this image belongs to the dog category with 92% kind of a confidence. Or maybe it's a cat category kind of image with 8% kind of a confidence. And just note that the image is being, it's a pixelated, right? So you can't post the image into the model. It needs to be converted into numeric form, like the bits, zeros and ones. So that's how the image recognition example also uses neural networks behind the picture, behind the hood. Okay. Now, what if I want to deploy that entire image recognition model in the production environment and just wanted to see how the users are interacting with the system? So in that case, how would be my machine learning pipeline or the workflow will look like? So let's see that. So in this infographic, you can see that the build, there are 3 stages actually. The first is a build stage, the second is a deployment, and the third one is a monitor stage, right? In the build stage, you're not just ingesting the data set as an input, but you're training the model on whichever data that you have ingested in your system. And then once you're training the model, you're also testing it out, whether the model is valid versus not, whether it's good enough versus not. So you're just creating all this kind of a build architecture or just pipeline behind it. And now once you're satisfied, you'll go in the deployment stage in which you're just doing some application testing and of course, just checking in the simulated environment how the model is working. And then you're packaging and just working on the CI/CD pipeline or just further production release. And towards the end, you have the monitor stage. So now when your model has been deployed in the real world scenario, you want to see how the model is performing over the period of time. And if the model is stale or not giving the good response, you'll again circle back to the build stage so that you can just re-ingest the new data set which has been provided over the period of time, or you can just train and improvise the model again and again. So that's how the machine learning pipeline or the workflow, I would say, looks like. But wait a minute, what if something goes wrong, especially in the testing paradigm, or I would say in one of the pillars of this ML pipeline? So let's see that. But before we understand the core part of my entire talk, which is, what's the black box and how we can build the fair and unbiased machine learning systems, I just want to cherry drop some of the questions so that it makes you ponder also. And for that, the first question, or I would say the statistic is, did you know that 13% of the machine learning models make it to the production? Does that imply that the 87 which are left over have never seen the light of the day? So that's what being reported by the venture beat, that unfortunately, the 87% of machine learning models, they never make it to the production, and only 13% of them actually is being deployed. So let's see what's the core and what's the reason and why there is such kind of a drastic difference. So that brings me to the core part of my talk, which is what is the black box problem? I'll just give you a couple of examples that will help you in comprehensively understand what the kind of a problem statement I'm trying to deal with it, and how we can both in a sense that me and of course you all can strategize and build some like fair and unbiased machine learning systems. So the first example which I want to give is, so this is a word-to-vec embedding. So what happens in the word-to-vec embedding is, you are given, so it's I would say it's kind of a vector space kind of a system that you have. For example, given a text data set, of course, the model, or I would say the system, will not understand the text, but it will understand it as a combination of zeros and ones or in a vector space. And here the word embedding space, it shows that the words which are similar in the meaning, they are close in the vector space, kind of a Cartesian plane, that, the words or the distances between the two words which are far apart implies they are not similar. So in that case, does that imply that the homemaker and the women, since the distance is very less, does that imply that they are similar in the meaning? Well, unfortunately, that's truth. And that's what the word-to-vec embedding kind of an algorithm is stating, that, the women and the homemaker, since they have the similar meanings, and therefore the distance is very much less. And similarly, there are other words and corresponding the vector space you can see is the man is a programmer, a woman is who kind of a homemaker, or you can see that the man is to a pilot and women is to a receptionist. So these are all pre-existing algorithms which are prevalent, and more often than not, data scientists and developers does use all these kind of embedding algorithms because they want to train the models, and of course before training the model they need to consume these kind of algorithms for that. So that's one example. The other surprising example I would love to give is ChatGPT. I'm pretty sure everyone would be using the ChatGPT. So I'll just give you a couple of seconds so that you can read through the prompt that I gave to the ChatGPT and its corresponding response, which is shocking to me, to say the least, but would love to hear the responses of the folks in here. Okay, so so the first prompt that I gave to the ChatGPT is, the doctor yelled at the nurse because he was late, and the question which I asked was who was late, and the response being given by the ChatGPT is the doctor yelled at the nurse because he was late. And the pronoun he refers back to the doctor. Well, unfortunately, I'm not stating the doctor is a he, right? I'm stating that the nurse was the one who was late, and therefore doctor yelled at him. So it was a nurse, not the other way around, not the doctor. So here you can see inherently how the algorithms are trained, and therefore the responses are so much biased and not well representative at the same time. So the next prompt which I gave to the chat GPT is the doctor apologized to the nurse for her late arrival to the emergency room. And then the question was, who was late previously, right? And here again, it seems that the doctor was the one who was late to the emergency room. And that's why he apologized to the nurse. I mean, I've clearly stated that it's a she, right? And that's why she apologized to the nurse for her late arrival. Her late arrival implies that the doctor is a she rather than he. So you can see how much bias is so much ingrained within these systems. But the question which I really want you all to ponder is, are we sure that the systems that we are consuming is not inclusive, or / are they biased, and what can be strategized towards it, and how can we mitigate that? So let's see the next, understand why in certain cases, machine learning models give so much unfair and biased results, and what's rational behind, and why there is so much disparity which is coming up. So there are a bunch of ways which I've listed in here. Again, that's not an exhaustive list, but it fairly, I think it covers more or less majority of the reasons why there is biased and unfair responses. So first of all, we know that the garbage in, garbage out, right? If you're feeding the biased data set as an input to the model, of course, you're going to get the biased responses as an output. And when you have the lack of diversity within the data set, which is not fully representative of the population that you're catering to or building a solution around it, then of course you're going to get the skewed results. The third is kind of in cognitive bias. See, that at that point, I feel like people, when they're not even aware about their inherent biases, then how can they mitigate it? So the best strategy, I feel like, having a collaborative work environment, which I'll definitely cover in my subsequent slides, but I think the cherry drop figure which I want to give is, of course, there's a cognitive bias which exists, and therefore there are so many unfair responses which comes in. The last one is when you have the inadequate evaluation metrics. So for example, you are trying to train a face recognition model, and then you are building a face recognition model which comprises about folks from a certain region, but not holistically. So then in that case, people from the minority section, since they're from the minority section at that point, they will not be able to bypass through the face recognition model, right? So your evaluation metrics are not in sync with what the use case that you're trying to cater to. In that case, you definitely will get unfair responses from the models, right? Now let's see how we can actually build a fair and unbiased model, and what are the ways we can build around it. Again, so the first thumb rule is, whenever you're trying to build any kind of face recognition, or maybe like any machine learning model or any use case that you're catering to, try to have diverse and representative data set, and then pre-process the data set as much as you can. So for example, you want to understand or do some hypothesis testing behind it, or just do some feature selection, feature engineering around it, data augmentation kind of techniques you want to implement, so that you're sure, or you're inherently knows what is in and out of that particular data set to which you want to build your model around. So that's these are the two thumb rule techniques that one should inculcate while they're building fair and unbiased models. The third one is, try to use kind of an algorithmic fairness technique. So what I meant by the fairness technique is, for example, you have built any loan classification model. I'll just give you an example also for that. What are the fairness techniques that we can use in subsequent slides? But the high level or the bird's view is, whenever you are building any ML system, try to understand how the response of that ML system is with regards to different groups within your data set. For example, if your data set comprises about folks within the age of 18 years and also belonging to certain gender, different genders and all of that, then just try to have an amalgamation of the groups in that case. Whether that model is actually catering to the particular section of the age group as well as particular gender, then in that case you can actually identify whether it is behaving fair or giving the fair and equal responses across multiple groups. So that's how we can use the some algorithm fairness techniques. And testing machine learning pipeline end to end. I'll also go in this ML test pyramid so that we can understand how we can do at testing at each and every stage while we are building this ML system. Okay. So I'll just give you the one very brief example of the fairness technique, which I was explaining in the previous slide. You can use some fairness techniques while you're building any kind of ML system in order to ensure that it is giving you the fair and unbiased result. So the example that I want to provide is, it's a loan classification example. And the data set that I'm using is a German credit data set that the folks from Germany, they have actually, it's an open source data set, again, available on the UCI repository, so you can definitely check it out from there. So this data set comprises of certain PII, which is a personally identified information that folks from particular gender, particular age, and what are the savings and corresponding things that you can see in this features. And then you're assigning the feature names to the data set of course, there are some categorical numerical data sets. So you do the pre-processing and understand the data set in a nutshell. And then you're defining what are the sensitive features within that data set. So here, the gender and the age, these are the two sensitive features within that data set. And loan classification problem in a sense that, okay, given a person's identity or an information, you need to identify whether this person will get a loan sanction versus not. So that's what a business use case is. And how we can ensure that, it's the model that are built in is a fair versus not. So a lot of fairness strategies that we can use and make sure that whether it is working out well across other groups versus not. We can definitely use one of those strategies, and that's called as a SMART. It's a data augmentation technique at the moment. So I mean, at the moment, in a sense that the data which is imbalanced data set. So when you have the imbalanced data set, also you need to use some feature engineering techniques, right? You need to ensure that the data is like highly representative. That's again what I mentioned in previous slide, as the thumb rule is have a diverse and well representative data set. So once you have the well representative data set, then you can see, okay, so the class labels of the 0 were like 59 before applying, and SMART is nothing but it's a statistical technique that you can definitely use while you want to balance the data set. And after applying the SMART technique, you can see the equal instances of the 0 and 1 which are available. 0 and 1 again are the class labels. So that's how we can apply one of the fairness technique in a sense that, oh, now the data is like well representative. We'll go also like on the modeling, that how we can model the data set and how we can test and ensure that the model that we have created is fair versus not, but that will come in like subsequent slides. Okay. So the next part is, let's see how we can build the ML test pyramid. Now we know, okay, the data set is being given, there are certain strategies that we can use in order to ensure that it needs to be fair and unbiased, but how can we ensure that the test is also done thoroughly on top of it? So for that, there are a bunch of techniques that we can use. First is unit testing, integration and model testing, and so on and so forth. So like in unit testing, you have like, there are various components in this ML system or ML pipeline. And that's what I showed in one of the infographics in previous slides. That you, in the build stage, when you are just training and ingesting the data set as an input to the model, and also when you're training the model, you need to ensure that every stage has proper unit tests being written on top of it. Like either it could be the feature extraction and whether the model is giving like the justified results versus not. In that case, you can use a model testing. For example, there are some PRF scores. PRF scores imply that precision, recall, and fairness. Precision, recall, and F1 score, which is precision, and also you can use some accuracy metrics. That whenever you're building kind of a classification model, that how much accurate your model is, how much instances it is able to justify. So that's some bits and pieces of the model testing that you can use. Deployment testing, again, when you have deployed a models, you just want to validate the model when it is in production environment and how it is working with regards to the real world scenarios. Robustness testing is definitely important when you want to actually test the possible edge cases which could be prevalent in particular use case of yours. So let's understand this entire ML test pyramid. Like I'll just cherry pick a couple of them and show you, how we can do some testing in while we are building ML systems. So, okay, I want to do a use case over here right now is a sentiment analysis. I'll just explain to everyone, folks in here, what's a sentiment analysis before I dig into it. So first of all, what's a sentiment analysis? For example, I can say that I don't like the pineapple on a pizza. I'm not sure how many folks within this room do love it, but definitely for me, I absolutely hate it. So I will say, it's a negative sentiment, right? And the other instance I can give is, for example, right now is, oh, I'm very much excited actually to Tina and of course the other organizers of this conference for giving me the opportunity to share my learnings with all of you. And it's kind of an humbling experience. So that's a positive sentiment, right? In similar way, you have certain sentiments which are attaching to every sentence that you are providing. So that's how we do the sentiment analysis. So again, for sentiment analysis, we need to import certain packages. And then once we have imported those packages, we are just building the sentiment analysis classifier in which you're pre-processing the data set, then you're building a pipeline, whichever the model that you want to use, and then you're training it. And once the model has been trained, like again, we use like set.pipeline.fit, then you're passing in the data set as well as labels as an input. Just a note on this example is it's a I would say it's a structure, and of course, it's a labeled data set. It's not unlabeled data set. So once you know the labeling of the data set, then it's become like it's easier problem in that case. So once the model has trained, now you want to just predict if the text, whichever particular the sentiment of that particular the data that you're trying to feed in, and then you will get the corresponding sentiment onto it. So that's the building sentiment classifier. Okay. Now we want to ensure that okay. The prediction given by the sentiment is corresponding to it. So you can see the one, I love the beaches in California. So it's a one. One is again a positive sentiment. This movie is terrible. It's 0 sentiment. So once you have trained it, then you want to ensure that the model is giving the correct predictions, and therefore you just run the predictions on top of it. And let's see, once you have done it, and then you can see the model testing. So in that model testing, you can see, okay, the accuracy of the model is approximately 80%, which is fair enough, right? Because the data set is like too small, and still it is giving like good accuracy, precision, recall, and then corresponding F1 score. So that's the small bits and pieces of the model testing that you can use. Of course, you can like thorough test cases in order to ensure that the data you are feeding in, it's also, you can perform some unit testing on top of the data set that you are doing. But for the model testing, again, you can calculate the PRS scores and accuracy that, oh, my model is giving 80% accurate. So again, I can improve it. I can use some hypothesis testing to improve the accuracy as well. But that's how we can do some model testing. But for the unit testing here, for the unit testers, I just want to be very clear in a sense that, oh, the data that I'm feeding in and how my model is actually giving the prediction. So whether it's, just kind of an assert statement, and of course, using the PyTest as one of the frameworks, which are available in Python, then you can just do the unit testing onto the predictions which are being given by that particular model. And then you just ensure that for whichever the training samples or the data set that you're providing, and then its corresponding labels are being marked, and which is kind of a given sentiment is equals to the expected sentiment, right? So that's how we can perform some unit testing on the predictions. There are, of course, unit testing in other bunch of cases that you can use, like for the pre-processing stage, after the prediction model has given, or during the testing stage as well. So these are certain aspects that we can cover. Okay, now the next question which comes in my head is, okay, fine, the model is trained, model has given good results. That's why we did the model testing, and we also did this unit testing just to ensure that the model is performing as to what is being expected. But how can we ensure that the model is fair enough? Fair enough in a sense that it is not giving biased responses towards any one particular section of the society. So in order to incorporate the fairness consideration while we are building the test cases, let's see that how we can ensure. So there are a bunch of techniques that we can use. The first is demographic parity, statistical, and again, I've just given as a funnel, but again, it's not like the headed, it's not a hierarchy. It's kind of people prefer to do equal opportunity difference, and that's kind of a very robust test cases where you can write. Then in that, the statistical parity difference, in which you can ensure that the model is actually giving the better results while you're doing the statistical parity. Basically, it just calculates kind of a difference in the positive outcomes being given by a model versus within your privileged and the non-privileged group. So what I meant by the privileged and the non-privileged group is, given a data set, right, you define what is a privileged group according to your hypothesis. For example, in this German credit data set on loan classification, I'm defining all the men beyond the age of the 25, they are privileged group, and all the women beyond the age of the 25 is an unprivileged group. And why I'm stating that is because the men population within that German credit data set was huge, and most of their credit values were also like greater than certain threshold. That's why I've defined, and I have not defined by my own gut feeling, but doing some hypothesis testing on top of it. So you just define your groups, and then you ensure that those groups are giving the fair responses, performing any of those fairness techniques or any of those fairness testing methods. And in the demographic parity is also like demography, right? It's a geography. So you want to ensure that people from different sections living in different parts of the world, they're also giving the justified response. The model is giving the justified responses. One very popular example I think I can give is, in like couple of years ago, Amazon released out one hiring algorithm. I think it was something like the algorithm was in itself was like, it was discarding the women applicants, those who had like same levels of years of work experience as well as the skills as compared to the male counterpart. Though it is no longer prevalent at the moment. Like I think Amazon has scraped it, and it was like huge news a couple of years ago. But the learning, or I would say the learning is, how that model was being released in the in the environment, or I would say in the production, and of course it was being used, that it's not well thoroughly tested, right? So that's how it was. So that's the reason. Okay, whenever you're building the ML systems, it needs to be like thoroughly tested, and you need to ensure that it's also like demographic parity and all these kind of fairness techniques you're incorporating, and just ensuring it's not kind of a penalizing on one group over the another, or just kind of creating kind of a favoritism over one group over the another. So once you have inculcated all these fairness techniques, then therefore the responses that we'll get is like fewer data-driven decisions, which will be given by the model itself, right? Let's see one particular example for this algorithmic fairness technique, which I would love to explain. Okay, so the example that I'm trying to give right now, it's again I'm just circling back on my loan classification example. In the loan classification example, what happened, right? You are given a data set as an input. You want to, and that data set has PII, also like a personal identified information of certain folks. And then you want to ensure, once you have created kind of a classification model around it, you want to ensure that, if a person from a minority section is using my model, they are not getting penalized. They will also get the fair and unbiased responses, right? So here I'm trying to use this equal opportunity difference kind of a metric. And in equal opportunity difference, again, you want to ensure that the model is not giving a huge difference in the true positive rate, or I would say the positive rate between the privileged and unprivileged group. And therefore, I calculated firstly the true positive rate. Here I'm defining the privileged and unprivileged group. And so basically you are belong to a certain gender and beyond the age of the 18, that's kind of a privileged group. And here the one is men. And again, the other privileged group is, this particular gender, and if it's greater than 18, so that's unprivileged group. And then once you have done it, I think should go on the second slide. Yeah. So here you can see the equal opportunity difference, the difference between both the groups. Once the model has been trained and evaluated, then it gives us 0. 0 implies that's a fair model, right? The model is not creating any kind of a favoritism or bias towards one group over the other. So that's how we can inculcate while we're building, these ML systems, that it's ensuring it's ensuring that it is fair and it's not biased at all towards one group over the other. So this leaves me the next part of the, I think, talk is, and I would love to ask the question from the audience again. I think Tina will also pose the same poll in here. So the question is, who should be responsible for ramifications of ML model? For example, if the model is giving some biased or skewed results, who should be one responsible behind it? And the options are developers or data scientists, of course, and clubbed in together, business leaders, regulatory bodies, or customers or the end users. I see someone has posted, developers are the ones who should be responsible. But I'm a developer. So it's so interesting to see the responses of the folks those who are responding to this question. I'm really thankful to the folks for being interactive and engaging in here. Okay, so I think I clearly see a very good tie-up. Oh wow! So developers and the business leaders, like it's like close tie which is happening between these two. So okay, the answer is together. It's like the answer is none of these. You can't pinpoint one person over the another. The developers are the evils behind it, or but I think everyone needs to work in sync, and everyone needs to work in collaboration, close collaboration. For example, the developers definitely they can't take up the stance by themselves, but stating that we will not build this kind of a model. But having a close collaboration, because they need to work with a close collaboration with the business leaders and other visionaries or the PMs and so on and so forth in the corporate hierarchy, and so that in that way, I think together we all need to make or just ensure that whenever we are building any such kind of model or systems, it's not biased towards one section versus the another. and every stakeholder kind of take the responsibility with kind of a plan and action. Interesting. Okay. So the next part of my talk is, how we can actually ensure the trustworthiness in ML systems. See, I've explained what is a fair, what is an unbiased, and how we can ensure that the models are going to be fair and unbiased. Now, I really want to understand, why we should actually trust these ML systems. We see that Tesla and all these autonomous vehicles and so on and so forth, that AI is so much embedded in our lives. But how can we actually ensure that they are transparent or they're actually trustworthy? So first of all, let's understand, the stakes at the how much stakes they are at risk. While if we are not trusting them, or if we are just creating kind of a hocus pocus kind of a situation. So here are the two examples I've given, like the autonomous driving in healthcare. I just want to circle back, and why I feel like the users need to kind of build a trust around such ML systems is because ML system for sure needs to provide the accurate, reliable, and unbiased responses, right, towards the end of the day. But if the users will not trust the system, of course, there will be kind of poor decision making, because sometimes, there are a lot of models which are right now coming up, which works on this RHLF, which is kind of a reinforcement kind of a mechanism that you are also providing the feedback in real time basis. But there will be like a lot of synergy or kind of a missed opportunities which will be missed if the users are not trusting onto the such kind of systems which are heavily consuming the ML technology or AI systems, especially like kind of in medical diagnosis, right, or in healthcare, the autonomous drivings and all these kind of applications. Like really, the stakes are so high. And therefore, the decisions made by the ML system will have significant impact on the folks' life, like people's life, right? Therefore, it's not just necessary that we need to build the trust around the ML systems so that they provide the reliable and accurate recommendations. But at the same time, I think the trust is kind of a two-way street, right? It's not, okay, we can't blindly trust this. After all, we just think that, it's the technology at the end of the day, which is true, but at the same time, the ML system need to be transparent. They need to be like explainable. And I'll go on that part of it. When I say like explainable, I'll explain what is explainable in ML systems. But I think, but before than that, I think the reason the ML system needs to be explainable is because users, when they are just trusting onto the systems, they need to know then how that particular system is working, what's the nuts and bolts behind that system, and how it is making certain decisions and why it is making certain decisions, right? And of course, the users also need to know who should be responsible and how they can be responsible. For example, if the Tesla makes a wrong turn and it could lead to certain injury or mishappening, then the user or the one who is behind the wheels will be the one who will be blamed, right? We can't say the Tesla is the one, or maybe like particular autonomous vehicle is the one who should be blamed at the same time. But again, working in synergy and also understanding and why the model is making certain decision, and who should be responsible and how should be the responsible, and how we can mitigate all these things. It's important that we need to build some trustworthiness around it. So let's see how we can actually build the trustworthiness or transparency in such ML systems. So there are like bunch of strategies which I have listed in here. First of all, collecting and high quality, high quality kind of a data set. So when you have the high quality data set, it not just well representative, but it needs to be also like a diverse. You want to prevent any kind of a bias which might possibly exist, and just want to ensure that it's fair enough. The second one is explainable and interpretable models. Whenever we are deploying or just using these ML models, they need to be transparent and interpretable, so that it increases kind of a trustworthiness, and therefore it will make the users more fascinated towards using that particular model. And of course, it reduces the risk of the black box kind of a problem, right? The next is kind of a monitoring. So when you just start monitoring your models and evaluating the models over the period of time and over continuously, then of course it builds the trust and also ensures the accountability. And when you involve like multiple stakeholders in this development process, it could be diverse range of stakeholders, could be the legal authorities, or maybe like a proper ethics kind of a team within the organization, or just experts in a particular domain, could be ethics, privacy, security, in the development process of this entire ML system, which will help in ensuring that the model is meeting the requirements, and of course that is going to satisfy all the needs of the particular stakeholders which are building such kind of a system. And regularly kind of an updating and improvising a model, it's kind of again a thumb rule, I would say. Not just helps in preventing any kind of outdated or biasness which could possibly present over the period of time. For example, if you have trained the model back in 2019 and it is still in the production, and because the data is changing, therefore you need to also redeploy or maybe like just update the model, right, over the period of time. So just maintain that kind of the pipeline which I've shown in one of the previous slides. So these are a bunch of strategies that you can use in order to ensure that the model is transparent and also like trustworthy. But I think I'll just go deeper into one of those strategy. That says explainability. You know, I've used explainability in my couple of slides previously as well. And if people are not aware, I'll be more than happy to explain what is like explainability. So explainability, you know, like you need to understand what the data has been used while you're training the model. For example, again, AI is becoming open source for sure, but there are so many other you know, the proprietary softwares or the models which are being used. Are you sure about what is the data which has been used behind training that particular model and why the model is giving some skewed results? So you need to know what the data was used while you're training the model, what features and weights have been used while it is creating that kind of prediction or real-time data-driven decisions, giving you some real-time data-driven decisions. And what kind of a thresholds, you know, like exactly what has been used, or just opening up that entire black box model and just wrapping it and also making it like human comprehensible. Then that's what I would say is explainability. Is explainability not just on the predictions why the model is giving certain decision, but what exactly was used behind the hoods and why the model is again giving that particular output. So that's what explainability is. Again, the underlying factors here should be human comprehensible. Even if the folks, those are not from the technical domain, they should be able to understand. Okay, so here is one very basic example of the explainability which I would love to give to all of you is the response. I think, okay, here, first of all, you are what the application, or I would say the use case is, again, it's on the sentiment analysis, circling back to one of my previous examples. So here the data set is, I love the beaches at Miami, and therefore the one is corresponding labeled to it, and it's a positive sentiment. You know, we have so many attendees and developers at this KWS QA conference, and therefore like it's a positive sentiment, right? And so you are attaching, like you are given a data set, and of course you are giving the labels also like as an input. So it's kind of a label data set. Now, once you have the label data set, you're using the vectorizer. And once you have trained the model, now you want to see how the model is performing. So here I'm saying, so excited in presenting. Again, we know that, you know, it's a positive sentiment. And therefore the model has also given like positive, and it has highlighted also the words which are contributing that why it is a positive sentiment, right? So that's how the explainability, or I would say human comprehensible it is. Okay, these are the words which are contributing, and highlighted with the orange states of the model is positive, and that's how it is giving, you know, it's a positive sentiment kind of a sentence. Okay. Okay, so now I just want to dig into what are the technical depths which happen while we are building such ML systems. And that's kind of a crucial part, because sometimes we actually deploy the models and just, you know, there is one very famous research paper which was kind of a hidden technical depths and MLs, hidden technical depths. In that way, I think whenever we are deploying, of course, we can't deploy the 100% perfect solution, but whenever we are creating and also reiterating and just providing the feedback mechanism plugged into our systems, we need to understand what are the possible technical depths which exist in the ML systems and how we can mitigate such depths. So a bunch of reasons, or I would say I've listed in here, are data depth, which is kind of, you know, when you're using kind of a low quality data set, and or maybe like some of the data set which lacks a representativeness. So therefore it is a data depth which is coming out. Or maybe like if you're using some outdated kind of or maybe like not using some optimal modeling techniques, because again, the LLMs which are, or AI is right now in the rapid space. Of course, you can keep a tab on the new LLMs or all these kind of new techniques. But at the same time, if you're relying on an algorithm which is being scraped up or has been updated like a couple of times and is still relying on that outdated algorithm, then of course you're going in that algorithm depth. And then is testing whenever you are not having thoroughly tested. Documentation is also for sure there when you have only one person who is behind the hoods working throughout, and there is not well documented. So if the new one or the new person wants to get onboarded, then it creates kind of a one person resource kind of a dip, right? Okay, the one person who's responsible should be able to give the KT to the other person, or not having the well representative in terms of the documentation. So these are like bunch of debts I think I have mentioned in here, and how we can actually mitigate those. So let's see that. First of all, you need to review your ML pipeline thoroughly. By reviewing, again, I meant by, like not just on the storage of the data set or data pre-processing stage, but whenever you're consuming such data set from different sources, and then you're building the model around it, and then you're training the model and testing the model, that entire pipeline, then you need to review it end to end. Second is checking the data quality. Again, poor quality data, or I would say the garbage in, garbage out, right? So poor quality data is kind of a major technical debt most of the times in ML systems when you are creating. So address them so that maybe like addressing them is like having a proper validation data set, having a proper training and the testing data set, which is not having a cross-functional within it. But again, it should be well representative and also like good chunk of the data set itself. And kind of looking for missing values. Sometimes the data set has a lot of, it's very sparse, it has a lot of missing values, it has some bias and label errors or some feature distribution errors. So in that case, you need to ensure that the data that you're collecting from multiple sources, it's also like, you're just going through the pre-processing stage thoroughly. It's also in a sense that it is well cleaned in that way. And then you need to examine your model performance. So again, the model accuracy might decline if you have the new data set which has been fed as an input to the model which is trained on existing data set. But again, there are so many hyperparameter tuning that you can do and ensure that the model is well accurate, or maybe like some of the threshold it is meeting, and it is not degrading over the period of time. Basically, just ensure that the model, sorry, or the data pipelines, if there needs to be like updated, and also has the latest techniques and the frameworks used behind the hoods. Fourth one is model explainability. Like you need to evaluate how the model is performing. Again, the example which I gave was like on a sentiment analysis, which is a very basic example. Similarly, there are other packages which are available, Line Sharp, FearML, all these kind of packages that you can definitely consume when you're building all these transformers or deep learning kind of models. And having thorough test cases, I think that's where more or less, I think building the model is not the end of the ML cycle, but having a thoroughly tested model is also equally important. So that's where I think most of the data scientists more often than not started actually using the TAD kind of principles while creating the models around it. So it's very important that you need to have not just the unit testing, but also like model testing and integration robustness testing, or just covering multiple edge cases throughout it whenever you're building ML systems. And performing the regular code update, which is kind of a last, I think, technique, or I would say how we can mitigate any kind of a technical debt. It's regular code update not just helps in kind of optimizing the existing code which are available, but I think also it helps in ensuring that you can actually refactor if there is kind of a repetitive code which is available in the entire code base. And having also like in the I think I forgot in saying that in the testing practices, when you are saying about automated testing practices, you want to also kind of catch regressions, right? Also just want to facilitate if there are some future changes which needs to be introduced, or maybe like which could possibly could give some new issues. So just ensuring that the comprehensive automated testing practices are being followed, end-to-end testing, like unit and of course integration testing, which helps in again building the stability of your code base. So I think these are a bunch of techniques I would say that we could adopt while we are facing any kind of a technical debt and ML system, while we are building systems. So that's towards the end of my talk, and that's a conclusion. You need to ensure that you are building thorough, well-tested model, or I would would say, the ML system around it. And of course, follow the practices of the ML test pyramid, which gives you very comprehensive and also gives you thorough test coverage for your ML systems. And having a TDD framework within it, within your model is also very important, because you want to ensure that it is fair, it's not biased towards one representative section of the society or one particular section of the society versus another. And also it ensures that your model is very transparent and explainable at the same time. And before I leave, I think I would love to leave you with one of my, I just enjoy writing a lot. So that's what I just want to leave you with a couple of my thoughts towards the end. That's like, from data's haze to ethics place in ML's maze, right? Let's shine the fair rays. Inclusion should be our mission, a colorful composition, and erasing biases should be our unwavering vision. So, and these are a bunch of resources for the reference. I think the second or then third one, the course, which is Introduction to Deep Learning by one of my professors from MIT. It's one of the best and brilliant course, and one can definitely check it out. And the first blog, it's also thoroughly written by a software engineer turned a data scientist, and he has written like comprehensively that how it's so much vital that while we are building ML systems, that it needs to be like thoroughly well tested. I think that's all I have for all of you today. Thank you so much for being a warm and lovely audience.
Thank you, Rashmi. I think you just raised the bar for conclusions on a presentation. I mean, writing a rhyming poem to summarize your talk, that is pretty awesome. Yeah, you've given us so much, so many great things to think about, and also, further reading and follow up. So that's amazing. It looks like we've got one hand raised. Maybe we have time for a quick question here. Rob, do you want to ask your question?
Yeah, sure. Thank you. Thank you so much, Rashmi. That was a fantastic presentation. Just a question around the automated testing aspect that you introduced there. How much of those different types of testing do you believe should be automated? And is there a certain type that should be left, like just for a human to check? Like, is there like an absolute truth or proportion there that you recommend?
Okay, I think these are like two questions embedded within one question. The first question that you asked me, how many test cases, or I would say which particular testing paradigm should be automated? That's the first question, right?
Yes.
Okay, so I think so like human involvement, it should be like vital in every part, whether you're building the unit test cases or whether you're building the I would say the deployment test cases. I think, but deployment test cases could be automated so far. It's very easy, but unit testers, I think it does involve like human interaction, and of course one needs to be like updating. If you're for example, if your model has been updated, then your unit test cases which are so brittle and which is being available on the pre-existing data set or pre-existing stages of your model, it will not work if you have updated your model. So having the human involvement in the unit test cases is like deeply, I would say, encouraged. But deployment test cases, or maybe like the integration test cases, I think it can be automated to a large extent. Yeah.
Okay, thank you.
There was also like one other part of this question, right, which I forgot actually. Could you just repeat?
Yeah, I was just asking if you, from your experience, is there like a proportion or such, or certain types? Well, let's just stick with proportion then, of how much you should make automated and how much should just be human oriented.
Right.
And actually, let me just add another question. Do you, if it's
Sure.
going to have automation in it, do you have you worked with ML ops, whereby you put it into a pipeline and a process whereby there are changes in the model that will trigger changes in the tests?
Yeah, so right now my pet project which I'm working on is building the MLOps framework from the scratch. Of course, I've seen a lot of MLOps frameworks which are available out there. But I think certainly to a very large extent, we can automate most of the test cases in a sense that, for example, like in MLOps, right? For if you want to just train your model on AWS or maybe like SageMaker or EC2 or any of the GCP cloud providers, right? In that case, if you want to just trigger your ML training towards it, you want to just ensure that the model is actually well it's performing really well in the real world scenario. In that case, you can actually automate a lot of test cases. For deployment test cases, integration test cases, you can definitely automate around those. But for unit test, I still feel, and I strongly hold very close to my heart, because for the unit test cases, I'm not just ensuring that the model is giving the expected versus the generated output thoroughly, but at the same time also just ensuring that the data which has been ingested in the model is also performing like, I mean, it's actually not a garbage value, honestly. So in that case, I think for sure, a huge part of our framework or huge part of the ML system can be automated through the ML ops, or using some of the concepts of the ML ops, and automating the existing test cases. Does
Great,
that
thank
answer
you. Yeah, thank you so much.
Great, thank you. Okay, I think we're out of time for today, but as I mentioned at the beginning, you'll receive a survey to give further feedback about the meeting today. And it looked like Rashmi had offered up her Twitter X handle as well, if you wanted to get in touch. So I'll post the recording for this session soon, and then you should be able to find both Rashmi's contact info and the links to the resources in there. So yeah, thanks again, and we'll hope to see you all soon. Have a great rest of your day or evening.